wormholes, and time travel. However, view of the nature of time has changed over the year. Until the beginning of the 20th century, people believe in an absolute time, that is, each event could be labeled by a number called time in a unique way, and all good clock would agree on the time interval between two events. However, the discovery that the speed of light appears the same to every observer no matter how he was moving led to the theory of relativity and the adorning of the idea that were a unique absolute time. The time of event could not be labeled in a unique way. Instead, each observer would have its own measure of time as recorded by the clock that he carried, and clock carried by different observer would necessarily agree and not. Thus, time became a more personal concept relative to the observer who measured it. Still, time was treated as if it were a straight line railway of which you could go only one way or other. But what if the railway line had loop and branches, so a train could keep going forward but come back to the station it has already passed? In other words, might it be possible for someone to travel into future or the past? H.G. Wells in the Time Travel explored those possibilities, as have countless other writers of science fiction. Yet many of the ideas of the science fictions, like submarines and travel to the moon, have become matter of science fact. So what are the prospects of time travel? It is possible to travel to the future, that is relativity shows it is possible to create a time machine that will jump you forward in time. You step into the time machine, wait and step out, and find that much more time has passed on earth than has passed for you. We don't have any technology today to do this, but it is just a matter of engineering. We know it can be done. One method of building such a machine would be to exploit the situation regarding the twins paradox. In this method, while you are sitting in a time machine, it blasts, often accelerating to nearing the speed of light, continues for a while depending on how far forward in time you wish to travel, and then return. It should not surprise you that a time machine is also a spaceship, because according to relativity, time and space are related. In any case, as far as you concerned, the only place you will be during the whole process is inside the time machine. And when you step out, you will find that more time has passed on earth than has gone by for you. You have traveled to the future, but can you go back? Can you create the condition necessary to travel backward in time? The first indication that the laws of physics might really allow people to travel backward in time came in 1949 when Godel discovered a new solution to Einstein's equation, that is, a new spacetime allowed by the theory of general relativity. Many different mathematical models of the universe satisfy Einstein's equation, but that does not mean that they correspond to the universe we live in. They differ from instance in their initial or boundary condition. We must check the physical prediction of models in order to decide whether or not they might correspond to our universe. Godel was a mathematician who was famous for proving that it is impossible to prove all true statements, even if you limit yourselves to try to prove all the true statements in a subject as apparently cut and dried as arithmetics, like the uncertainty principle. Godel incomplacent theorem may be a fundamental limitation on our ability to understand and predict the universe. Godel got to know about general relativity when he and Einstein spent their later years at an institution for advanced study in Princeton. Godel, space-time has a curious property that a whole universe was rotating. What does it mean to say that while the universe is rotating, to rotate means to turn around and around, but does not that imply the existence of a stationary point of reference? So you might ask, rotating with respect to what? The answer is a bit technical, but it is basically the distance matter would be rotating with respect to direction that little top of gyroscopic point in within the universe. In Godel space-time, a mathematical side effect of this was that if you travel a great distance away from the Earth and then return, it would be possible to get back to Earth before you set out. That his equations might allow this possibility really upset Einstein, who had thought that general relativity would not allow time travel. But although it satisfies Einstein's equation, the solution Godel found does not correspond to the universe we live in, because our observation shows that our universe is not rotating, at least not noticeably. Nor does Godel universe expand as our does. However, since then, scientists studying Albert Einstein equation have found that other spacetime allowed by relativity thus do permit travel into the past. Yet observation of the microwave backward and of the absence of the elements such as hydrogen and helium indicate that the early universe did not have a kind of curvature those models required in order to allow time travel. The same conclusion follows on hypothetical ground if there is no boundary proposal is correct. So the question is this: if the universe start out without the kind of curvature required for time travel, can we sufficiently warp the local region of space-time sufficiently to allow it? Again, since time and space are related, it might not surprise you that a problem closely related to the question of travel backward in time is the question of whether you or not can we travel faster than light. The time travel implies faster than light travel is easy to see. That time travel implies faster than light travel is easy to see. By making the last phase of our trip a journey backward in time, you can make your recall trip in a little time as you wish. So you will be able to travel with unlimited speed. But as we will see, it also works the other way. If you can travel with unlimited speed, you can also travel backward in time. One cannot be possible without the other. The issue of faster than light travel is a problem of which concern to writer of science fiction. The problem is that, according to relativity, if we send a spaceship to our nearest star, neighboring star, that is Proxima Centauri, which is about 4 light years away, it would take at least 8 years before we could accept the traveler to return and tell us what they had found. And if the experimentation were to be the center of our galaxy, it would be at least 100,000 years before it come back. Not a single situation if you want to write about intergalactic warfare. Still, the theory of relativity does also one conclusion. Means against along the line of our discussion of the twins paradox, it is possible for the journey to seems to be much shorter for the space travel for that those who remains on Earth. That is Doppler effect like. But there would not be much joy in returning from a space voyage a few years older to find that everyone you had left behind were dead and gone 1,000 of years ago. So in order to human or have any human interest in their stories, science fiction writers had to suppose that we would one day discover how travel or how faster the light travel. Most of these authors do not seem to be realize that the fact that if you can travel speed than light, the theory of relativity implies you can also travel back in time. As the following Rimsey say, there was a young lady of wits who traveled much faster than light. She departed one night in a relative way and arrives on a previous night. The key to this connection to that the theory of relativity says no only that there is no unique measure of time, now which observation or observer will agree with, but under certain circumstances, observers need not even agree on the order of events. In particular, if two events A and B are so far away in or just far away in space that a rocket must travel faster than the speed of light to get from event A to event B, then two observers moving at different speed can disagree on whether event A occurs before B or B events occur before A. Suppose, for instance, that event A is the finishing of the 100-meter race in 1212 and event B is the opening of the one-legged 4 meeting of the Congress of Proxima Centauri. Suppose that to an observer on Earth, event A happens first and event B. Let's say that B happens a year later in 2013 by Earth time. Since the Earth and Proxima Centauri are some 4 light years apart, those two events satisfy the above conditions. Through A happens before B, to get from A to B, you would have to travel faster than the speed of light. Then, to an observer on Proxima Centauri moving away from the Earth at nearby, the speed of light, it would appear that the order of the events is reversed. It appears that event B occurs before event A. This observer would say it is possible if you could go faster than light to get from event B to event A. In fact, you will really fast. You could also get back to A to Proxima Centauri before the race and place a belt on it or sure knowledge of who will win. There is a problem with breaking the speed of light barrier. The theory of relativity says that a rocket power needed acceleration as spaceship get started and get greater and greater the nearer is speed to get to the speed of light. We have experimental evidence for this, not with spaceship, but with elementary particles in particle accelerators, such as those of the Fermi of the European Center for Nuclear Research. We can accelerate particles to 99.99% of the speed of light, but however much power we feed in, we cannot get them beyond the speed of light barrier. Similarities with space-time. No matter how much fast the rocket move or how much power they have, they cannot accelerate beyond the speed of light, and since travel backward in time is possible, if it's faster than light, travel is possible. This might seem to rule both rapid space travel and travel back in time. However, there is a possible way out. It might be that you could warp space-time so that there is a shortcut between A and B. One way of doing this should be create a wormhole between A and B. As its name suggests, a wormhole. A wormhole is a thin tube of space-time that can connect it to nearly flat region far apart. It is somewhat like being at a base of a high ridge of mountain. To get to the other side, you would normally have to climb a long distance up and then back down. But not if there was a giant wormhole that cut horizontally through the rock. You could imagine creating or finding a wormhole that would lead for the vicinity of our solar system to Proxima Centauri. The distance through the wormhole might be only a few million miles. Even though the Earth and Proxima Centauri are 20 million miles apart in ordinary space. If we transmit the news of the 100-meter race through the wormhole, there would be plenty of time for it to get there before the opening of the Congress. But then, an observer moving toward the Earth should also be able to find another wormhole that would enable or just able to him to get from the opening of the Congress on Proxima Centauri back to the Earth before the start of a race. So wormhole, like any other possible form of travel faster than light, would allow you to travel into the past. The ideas of wormhole between different regions of space-time is not an invention of science fiction writers. It came from a very respectable resource. In 1935, Einstein and Nathan Rosen write a newspaper in which they showed that general relativity allows what they called bridge, but which are not known as wormhole. The Einstein-Rosen bridge did not last long enough for a space-time to get through. The strip would run through into the singularity as a wormhole pinched out. However, it has been suggested that it must be possible for the advanced civilization to keep a wormhole or the wormhole open. To do this or to wrap space-time in any other way as to be permitted time travel, you can show that you need a region of space-time with negative curvature like the speed of a sandal or the surface of a sandal. Ordinary matter which have positive energy density give space-time a positive curvature like the sphere or the surface of the sphere. So what is needed is order to warp space-time in a way that will allow travels into the speed or the past is matter with negative energy density. What does it mean to have a negative energy density? Energy is a bit like money. If you have a positive balance, you can distribute in a various way. But according to the classical law that were believed a century ago, you were not allowed to have your bank account overdrawn. So this classical law would have rules out negative energy density and hence any possibility of travel backward in time. However, as had been described in earlier chapters where just previously, the classical laws were superseded by quantum law based on an uncertainty principle. The quantum laws are more reliable and allow you to be overdraw one or other two accounts provided the total balance is positive. In other words, quantum theory allows the energy density to be the negative in some places provided that this is made for of positive energy density in other places so that the total energy remains positive. We thus have reason to believe both have time, space, or the space-time can be warped and that can be curved in a way necessary to allow time travel. According to the Feynman sum over histories or the histories, time travel into the past does it a way occurs on a scale of single particles. In Feynman method, an ordinary particle moving forward in time is equivalent to an antiparticle moving backward in time. In this mathematics, You can regard a particle or an antiparticle pair that are created together and then inherit each other as a single particle moving on a closed loop in spacetime. To see this, first picture the process in a traditional way. At a certain time, say time a particle and an antiparticle are created. Both move forward in time. Then at a later time, time v, they interact again and inherit each other before A and before B. Another particle exists. According to Newman thought, you can look at it differently. At a single particle is created. It's moved forward in time to B, then it returns back in time A instead of a particle and antiparticle moving forward in time together. There is just a single object moving in a loop from A to B and back again. When the object is moving forward in time from A to B, it's called a particle. But when the object is traveling back in time from B to A, it's a pair and antiparticle traveling forward in time. Such time travel can produce observable effect. For instance, suppose that one member of a particle or just antiparticle pair, says antiparticle, fall into a black hole, leaving the other member without a partner with which to inheritance. The forsaken particle might fall into the hole as well, but it might also escape from the vicinity of the black hole. If so, to an observer at a distance, it would appear to be a particle emitted by the black hole. You can, however, have a different but equivalent picture of the mechanism for emission of the radiation from black hole. You can regard a member of the pair that fall into the black hole as a particle traveling backward in time out of the hole, but it gets to the point at which the particle and antiparticle pair appears together. It is scattered by the gravitational field of a black hole into the particle traveling forward in time and escaping from the black hole, or if instead it was a particle member of the pair that fell in a hole, you would regard it as an antiparticle traveling back in time and coming out of the black hole. Thus, the radiation by black holes shows that quantum theory allows time travel back in time on a microscopic scale. We can therefore ask whether quantum theory allows the possibility that once we advance in science and technology, we might eventually become to build a time machine. At first sight, it seems it should be possible. The Feynman sum over history proposal is supposed to be over all histories, or the histories. Thus, it should include histories in which space-time is so warped. It is possible to travel into the past, yet, even if the known laws of physics do not seem to rule over it, or out of time travel, there are other reasons to question whether it is possible. One question is this: if it is possible to travel into the past, why has not anyone come back from the future and told us how to do this there? Might be good reason why it could be universe or unwise to give us the secret of time travel at our present primitive state of development. But unless human nature changes radically, it is difficult to believe that some visitor from the future would not spill the beams. Of course, some people would claim that signing of UFO are evidence that we are being visited either by aliens or by the people from the future. Given the great distance of other stars, if the aliens were to get here in reasonable time, they would need faster than light travel, so the two possibilities may be equivalent. A possible way to explain the absence of visitor from the future would be to say that the past is fixed because we have observed it, saying that is not just have a kind of wrapping needed to allow travel back from the future. On the other hand, the future is known and unknown and open, so it might well have a curtain or the curvature required. This would mean that any time travel would be confirmed to the future. There would be no chance of Captain Kidd's and the starship Enterprises turning out at the present time. This might explain why we have not been even overcome or the overrun by tourists over the future, but it would not avoid another type of problem, which arises if it is possible to go back and change history. Why are not we in trouble with history? Suppose, for example, someone had gone back and given the Nazis the secret of the atom bomb, or what you went back and killed your great-great-grandfather before he had children. There are many versions of this paradox, but they are especially equivalent. We would get contradiction if we are free to change the past. There seems to be two possible resolutions the paradox proposed by time travel. The first may be called the constituent histories approach. It says that even if space-time is curved, so that it would be possible to travel into past. What happens in space-time would be a consequent solution of the laws of physics. In other words, according to the viewpoints, you could not go back in time unless history already shows that you had gone back and while there had not killed your great grand or committed any other act that would conflict with the history of how you got to your current situation in the present. Moreover, when you did go back, you would not be able to change recorded history. You would merely be following it. In the views, the past and future are coordinated. You would not be free will to do what you wanted. Of course, you would say that free will be an illusion anyways. If there really is a complete history of the theory of physics that govern everything, it presumably also determine your action. But it seems so in a way that are impossible to calculate for an organism that is complicated as a human beings and is involved a certain randomness due to quantum mechanical effect. So one way to look at this, we say humans have free will because we cannot predict what they will do. However, if a human then goes off on a rocket ship and come back before his setup, he would be able to predict that he will do because it will a part of a recorded history. Thus, in that situation, the time travel would not be any sense have free will. The third possible way to resolve the paradox of space-time might be because the alternative histories hypothesis. The idea here is that when time travel go back to the past, they enter alternative histories that or the alternative reality that differs from recorded reality or just recorded history. Thus, they can act freely without the constraint of consistency with their previous history. Steven Spielberg had fun with his notation in a Back to the Future film. Marty McFly was able to go back and change his parents' courtship to be more satisfied history. The alternative historic hypothesis sounds like Richard Feynman's way of expressing quantum theory as the sum of our histories. For the histories, these said that the universe did not just have a single history. Rather, it has every possible history, each with its own possibility. However, there seems to be an important difference between Feynman's proposal and alternative histories. In Feynman's song, each history comprises a single spacetime and everything in it. The spacetime must be so wide that it is possible to travel in a rocket into the past, but the rocket would remain in a same spacetime and therefore the same history, which would be have to constant. This thus Feynman's sum over histories proposal seems to support the consistent histories hypothesis rather than the ideas of alternative histories. We can avoid these problems if we avoid that by just adopting what we might call the canonically protection conquer or the conjecture. This says that the laws of physics conspire to prevent microscopic bodies from carrying knowledge or information into past. The conjecture have not been proved, but there is a reason to believe it is true. The reason is that when space-time is warped enough to make time travel into the past possible, calculation employing quantum theories shows that particle and antiparticle patterns or the pairs moving around and around on closed loop can create energy density large enough to give space-time a positive curvature, counteracting the warp pages that allow the time travel because it is not clear whether it is so. The possibility of time travel remains open but does not bet on it. Your opponent might have the unfair advantage of knowing the future, and that type of things have the creation of parallel universe.